today we're going to be learning about basic concepts. We've learned about trigonometric functions in class 11th. Now let us recall the domains and ranges of all 6 trigonometric functions. Let us start with the sine function. The domain of sine function is all real numbers, which is denoted by r, and the range of sine function is closed interval -1 to 1. Let us take a function sine of x equals to y. Learners, can you tell me the value of x and y? Well, the value of x can be any real number and the value of y will be -1 to 1. Now, let us discuss about cosine function. The domain of cosine function is all real numbers, which is denoted by r, and the range of sine function is closed interval -1 to 1. If we take an example, cosine of x equals to y, here the value of x can be any real number and the value of y will be -1 to 1. Learners, let us move to the tangent function. The domain of the tangent function is all real numbers except the value of 2n plus 1 times pi over 2, where n is any integer. If we put the value of n as 0, then x will be pi over 2. If we put n equals to 1, then x will be 3 pi over 2. Again, if we put n equals to 2, the x will be 5 pi over 2. We know that for pi over 2, 3 pi over 2, 5 pi over 2, tangent is not defined. So the domain of tangent is any real number except such numbers. The range of tangent is any real number. Now let us take cotangent function. The domain of cotangent function is any real number minus x, such that value of x is n pi, where n is any integer. If we put n equals to 0, x will be 0. If we put n equals to 1x, it will be pi. We know that cotangent is not defined for 0, pi, 2 pi, and n pi. So the domain of cotangent is any real number except such numbers. The range of cotangent is any real number. Now let us consider second function. Learners, second function is 1 over cosine function and tangent is sine over cosine. Have you ever noticed that tangent and secant both have cosine as the denominator? Because of this, their domains are the same. That is, the domain of second function is all real numbers minus x, such that x equals to 2n plus 1 times pi over 2, where n is any integer. The range of second function is all real numbers minus -1 to 1. Finally, let us consider the cosecant function. The cosecant function and cotangent function have sine as the denominator. Cosecant function is 1 over sine function and cotangent function is cosine function over sine function. Hence, the domains of cosecant function and cotangent function are the same. That is, any real number minus x, such that value of x is n pi, where n is any integer. The range of second function is all real numbers minus -1 to 1. So learners, these are the ranges and domains of the trigonometric functions. Learners, we have also learned about functions and inverse functions. Let's recall them. If f is a function which is moving from set x to set y, such that f of x equals to y is 1, 1 and onto, then we can define a unique function g which is moving from set y to set x, such that g of y is equal to x, where x belongs to capital X and y equals to f of x. Also, y belongs to capital Y. Here the domain of g equals to range of f and the range of g is equal to domain of f. The function g is called the inverse of f and is denoted like this. Moreover, g is also 1, 1 and onto, and inverse of g is f. Thus, the inverse of g is equal to the inverse of f, which is equal to f. Learners, we know that trigonometric functions are periodic functions, and generally all trigonometric functions are not bijections, and hence their inverses do not exist. But if you restrict their domains and codomains, they can be made bijections, and we can get their inverses. So learners, in today's video, we have recalled the domains and ranges of 6 trigonometric functions. We also recalled the inverse of a function. Thank you for watching this video.